Okay, today we're looking at section 8.4, which is multiplying special cases. Hopefully by the end of the section you can say that I can find the square of a binomial and I can find the product of a sum and a difference. So let's look at a few today. First of all, if I asked you to find this product, a couple different ways you could do it. First thing we got to realize though is that x plus 5 squared really means x plus 5 times an x plus 5. So once you write it out like that, you could do the distributive property, you could FOIL it. I like to use the box, so I would just use this. So I'd have x squared, a 5x, a 5x, and a 25. So my final answer would be a x squared plus 10x plus a 25. Okay. Then if I looked at this one, if I want to find the product here, again, we realize that it's x minus 4 times an x minus 4. We got an x and a negative 4, x and a negative 4. So we got x squared, a negative 4x, a negative 4x, and a 16. So I would get an x squared minus 8x plus 16. Okay. So if I wanted to do this one, I'm going to change it just a little bit. Let's try and do a 2x plus 3 squared. Okay, so this would be a 2x and a 3, 2x and a 3, so this would be a 4x squared. This would be a 6x, this would be a 6x, this would be a 9. So altogether, I've got a 4x squared plus 12x plus 9. Okay. Next one we're going to look at is this would be the product of a sum and a difference. So if you take a look here, I've got an x plus a 3 and x minus a 3. So this, we get an x squared, we get a 3x here, we get a negative 3x squared here, and a negative 9. So the two middle terms cancel out, and we're just left with an x squared minus a 9. Okay, if we look at the same sort of thing here, we'd have an x and a negative 4, an x and a 4. So I'd have an x squared minus 4x, a 4x, and a negative 16. So when you combine like terms, you end up with an x squared minus 16. Okay, so the next thing, we got a question. The question is, what patterns do you see? So first of all, let's look back at the squares. If we square something, was there a pattern? And hopefully we can see that these two terms here are identical. Each time we do that, if we take and we square a binomial, these two terms end up being identical. Okay, so that's the first thing that we should look for. So if I said this, a pattern, like if I said an x, let's write it as this, an a plus a b squared. So if I'm taking something and I'm squaring it, hopefully we can see that I get an a squared, the first thing squared. That would be like this right here. The 4x squared came from a 2x times a 2x, which is the a term squared. Okay, hopefully we can see that I got 2 of these terms, which, when I flip back here, those 2 terms would be these terms that we circled here, which came from multiplying the first term and the last term. So that's why I say it's 2 times AB. And then the last part is just the b squared. Okay, very similarly, if I did a subtraction and we square it, hopefully we could see that it would just, the only thing that would change would be this middle term would be a minus 2b squared, 2ab, excuse me. Okay, and then hopefully we can also see that if I had a plus a b times an a minus b, this would be the sum and a difference that we're talking about. Here we have, okay, so here, hopefully we could see that I got the a term squared always minus the b term squared. Okay, so maybe a side note, if I asked you to do one of these really quickly, if I said take 2x plus 7 squared, hopefully we can see that, okay, I'm going to have to take the 2x's squared, so that would be a 4x squared. I'm going to have to take 2 times the first term times last term, and I'm going to have to take the last term and square it. So I'd have to take 7 squared. So I'd have a 4x squared plus 28x plus 49 for that one. Okay, or if I asked you down here to do a 3x minus 6 times a 3x plus a 6, hopefully we can see that that's going to be the 3x times the 3x would be a 9x squared, and then minus a 36. That would be your final answer. Okay. Hopefully this is making sense to us. That's all I've got, so that is a wrap.